downtown, walking fast, faces pass and I'm homebound.
Good morning, good afternoon, good evening. We are back and better than ever. Little known fact, Miss Vanessa Carlton was making her way downtown because she was headed to calculus class. That's right. And today we are talking about rates of change, which is the whole point, for the most part, of the derivative. So, getting into some cool applications. We have already talked about that with displacement. The derivative of it is the instantaneous rate of change of the displacement, which is the velocity. And it gives some good examples here as to where we might use this. And that would be with temperature, height of a tree, or anything that grows. Stocks change all the time. Everything in life, almost everything in life, is changing constantly. That's why calculus is awesome with a capital A. So we can use the derivative of a function to tell us the rate at which something is happening. For example, just a couple of them here. Instantaneous rate of ascent of the person in a Ferris wheel. Ooh, I got to give Geo her exam, so let us move that till the end of today. Okay. dc dt could be a person's instantaneous rate of change in lung capacity. Ooh, a medical application. Change is always happening in life, so we can predict change using calculus. Let's have a look-see, shall we? According to a psychologist, the ability of a person to understand spatial concept is given by this function, where t is age in years for ages 5 through 18, including them both. Okay, so part A, let us find the rate of improvement in ability to understand spatial concepts when a person is 9 years old and 16 years old. Rate of improvement is a rate of change, and so for part A, we have to find the rate of change, and that means we have to find the derivative of A, which I'm going to rewrite as 1/3 t to the 1/2. So the derivative of A is equal to 1/6 t to the negative 1/2, which is equal to, let's see, 1/6 root t. Okay, so A prime of 9 is equal to 1/6 times the square root of 9, which is equal to 1/18. Okay, and then A prime of 16 is going to be equal to 1/6 times the square root of 16, or 1/24. Skipping all of that to save time because you all know how to do that. Okay, so they also say, well, they don't ask us, but let's go ahead and say what this means. This means that the rate of improvement is 1/18 units, whatever those units the psychologists use may be, but 1/18 units per year for a 9-year-old, and the rate of change of understanding spatial concepts for a 16-year-old is 1/24 units per year. Okay, so let's take a look at B. Explain why the derivative, the first derivative, is greater than 0 for 5 less than or equal to t less than or equal to 18. Well, that's easy, because the square root of t will always be greater than or equal to 0. Therefore, for 5 less than or equal to 18. Okay. Square root is always greater than 0. Therefore, 1/6 root t must always be greater than 0. So that's pretty easy. The significance of this result is that the ability to understand spatial concepts is always improving, because it's always going to be positive. It's always increasing. And then finally, C, explain why d2, the second derivative, is less than 0. So the second derivative is obviously the derivative of the first derivative, which we have right here. So I'm going to say that's equal to negative 1/12. Let's see, t to the negative 3/2. Is that correct? I believe it is. Which is equal to negative 1 over the square root of t cubed, which I could also write as negative 1 over t root t. And of course, I forgot the 12, so I'll put a 12 in there too. Sorry. So it's negative because it's always going to be negative because root t is positive and I have a negative in front of here. My time is always positive because of the domain of the function. So therefore, that's why it is always negative. And what does this mean? Well, that means the change in understanding spatial concepts will always be decreasing. Okay? The rate of change will be decreasing. That's evident here. When you're 9 years old, the change is 1/18 units per year. And when you're 16 years old, the change is 1/24 units per year. And 1/24 is certainly less than 1/18. So the rate of change will always be getting less and less and less. That's what that means. Okay, next example. The cost in dollars of producing X items in a factory each day is given by this cost function. And labor, raw materials, and fixed costs. Okay, so some company or some factory used this to calculate its cost in dollars. So find C prime of X, which is called the marginal cost function. So that's pretty simple, C prime of X except for the decimals. I'm going to cheat and tell you that is equal to 0. I guess it's really not cheating, it's not that hard. 0.0039x squared plus 0.004x plus 5. Okay, so that's A. So B, find the marginal costs, that's the derivative, when 150 items are produced. Interpret this result. Okay, so C prime of 150, meaning we replace X with 150, and I will save you the trouble, and I will tell you that's equal to $14.38. We know it's in dollars because that's what it says right there. Okay, so if you replace X with 150, you get $14.38. Now, what in the world does this mean? Well, this is the rate of change, the rate at which the costs are increasing. They're increasing because this is positive with respect to the production level X, producing X items, okay? So this is the change in cost with respect to the production level X when 150 items are made per day, right? So this is the change right at 150, okay? And this is an important concept. So if the change is at 150, it's an estimate. It's an estimate of increase to cost of producing the next item. Okay, hopefully that makes sense. If not, we can talk about it more in class. The next item would be the 151st item. Okay, why? Because the cost is changing. After we've produced the 150th item. Okay, C. Find C of 151 minus C of 150. So it's the cost of 151st item minus the cost of producing the 150th item. How do we do that? Well, we replace X with 151 in the cost function and then subtract the cost of replacing X with 150. And I will tell you that that is approximately equal to $14.44 because there's a rounding issue there. And what does that tell us? Well, this is the actual cost, and what it tells us is the derivative is a decent estimate. What? We're only 6 cents off. Okay, there is one more example. I'm going to stop the video here and do that on a separate video, and we'll see you next time.